Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. OpenAI developer SQ demonstrates the GPT-5.4 thinking model through live application builds that expose a fundamental reversal in AI economics. Higher autonomy is now driving costs down rather than up. His demos reveal agents that test software by playing games through the user interface and verify websites by comparing screenshots side by side, treating visual experience as the primary validation method rather than code inspection. SQ works as a model training engineer at OpenAI, concentrating specifically on improving AI capabilities for web and application development with particular attention to user experience design. He presented these demonstrations during the official GPT-5.4 thinking product launch, showcasing the model's new computer use functionality for end-to-end application creation. Standard industry assumptions hold that agency costs scale upward with capability. SQ's data on the GPT-5.4 thinking model's persistent computer use feature, called KUA, reveals token consumption has dropped by 2/3 compared to previous implementations. This contradicts expectations because agency typically demands maintaining context across multiple applications, which should burn processing resources. The engineering explanation centers on environmental persistence. Earlier systems like Codex required spinning up fresh environments for each interaction, consuming tokens merely to establish context before performing any actual work. The new persistent environment allows the model to remain active within a continuous session, eliminating repeated initialization overhead. The model operates continuously like a human user rather than rebooting between tasks, transforming agency from a computational burden into an efficiency mechanism. SQ's demonstration methodology reveals his confidence in the system's robustness. When building a 3D chess application, he intentionally increases difficulty by requiring the model to render pieces with complex visual effects, transparent glass textures, and marble surfaces. These aesthetic constraints serve no functional purpose. They exist solely to stress test the model's ability to handle sophisticated rendering demands during live execution. The chess demo exposes a structural shift in how AI systems validate their own output. Traditional software testing separates the creator from the tester code, gets written, then separate validation scripts verify correctness. SQ shows the model constructing the chess application and then actively playing the game itself, using the graphical interface to move pieces and execute a castling maneuver. The AI verifies functionality not by analyzing source code, but by experiencing the application as an end user would. This creates a feedback architecture where the system understands software through visual and interactive signals rather than abstract syntax, debugging transitions from examining text to observing behavior. During the live demonstration, SQ reacts with visible excitement when the model executes the castling move unprompted, exclaiming about what just occurred on screen. His spontaneous reaction underscores how significant this behavioral validation is. The system exhibits emergent comprehension of game rules through user actions rather than programmatic logic. The visual validation capability extends into web design workflows in ways that challenge conventional development processes. Standard practice for matching a website to a design mockup involves manually checking pixel coordinates and color codes, a tedious process prone to human error. SQ presents a scenario where the model functions as a visual designer with human-like aesthetic judgment. When tasked with replicating a coffee shop website from a static image, the model opens both the reference design file and the live site it just built, positioning them side by side on screen. It then inspects the visual differences directly, assessing aesthetic alignment rather than comparing code. This represents the model checking its own work through visual perception. Additionally, the model recognizes that image generation represents a processing bottleneck and triggers concurrent generation of 4 different assets simultaneously. This behavior blends machine execution speed with human-like visual assessment, treating creative work as a parallelizable computational task while maintaining aesthetic coherence through visual comparison. A personal detail adds depth to this coffee shop demonstration. SQ shares that his partner Nancy has long aspired to open her own coffee shop. She created a design for her ideal website, which SQ then used as the actual prompt for this demo. The model transformed a non-technical person's creative vision into a functional working site, turning a personal dream into a practical demonstration of the AI's ability to bridge the gap between creative intent and technical execution. For business leaders and development teams, the strategic implication is immediate. If autonomous agents now cost less to operate than scripted automation environments, the economic rationale against deploying AI for complex workflows has dissolved. Budget models built on assumptions that agency equals expense require immediate revision. If you're interested in the video featured in this episode, click the link below to watch the original.